Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now the topic is fundamental concept of chemistry, that is organic chemistry. This is for class 10, 11th and 12th, and it is part 10 where carbonium ion and carbine, that one I have to explain. Now first we will see carbonium ion. What is meant by carbonium ion? It is a positive charge one where the positive charge is existing on carbon. So carbon having positive charge and 6 electrons. So what is meant by 6 electrons? Sextet. Sextet means 6 electrons that is present in the carbon. So that is why, and it is called carbonium ion. Then how can you explain? Or it may be explained properly, a group of atoms where one carbon in center which has 6 electron and positive charge. How we will get positive charge? By only heterolytic fission. Heterolytic fission, here we will see how the bond is breaking. Which bond? Covalent bond is breaking. Covalent bond is breaking mean there are two types of fission, homolytic fission and heterolytic fission. We will see here what is meant by heterolytic fission. Heterolytic fission means pair of electrons move towards the more electronegative atom during fission. When heterolytic fission occurs, the pair of electrons, that what is the pair of electrons? That means this pair of electrons which forms the covalent bond. And now see here, this is the covalent bond is formed by the sharing of this pair of electron. When you see this pair of electron is responsible for covalent bond, and here you can see, and this is our a dot, a pair of dot. Pair of dot mean that is pair of electrons. Here you can see here pair of electron represents that is covalent bond, and here you can say one should be high electronegative and other should be lower electronegative. That means the electron pair when moves towards B and B acquires negative charge, sure that B is more electronegative than A. A plus has sextet of electron. That means A plus, what happened here? Because 2 electrons gone to B that is having minus charge now. So A having less electron, that is sextet of electron and has a positive charge. If it is C, then it is called carbonium ion. For example, you can see one organic compound RCH2X on heterolytic fission. What happened? X is more electronegative than other part. That is why this pair of electron, what happened here? This pair of electron and moves towards to X. Then what happened here? R C plus HH. That means here C plus having positive charge, and this part, this is called carbonium ion. Then you will see if what happens to an ion if it is present to our carbon, that is called carbonium ion. And how can we present? Having positive charge, because you can see 4 valencies should satisfy by carbon. If it is that is mean it is having 8 electrons and 4 covalent bonds. Here one side there is no covalent bond, one side there is a plus charge, positive charge. That is why it is called carbonium ion. Carbonium ions are named. How can you name? Actually by IPC name. How can you name it? That means IUM. That means to the parent alkyl group. Parent alkyl group what? Methyl, ethyl, propyl, isopropyl, like this. So here if the carbon containing positive charge, you will see what is the type of parent alkyl group. To that you add IUM, alkylium. So now it is methyl group. See, this is the methyl group, and here it is methyl attached to the positive charge. So what happened? Methylium. And you see this is the primary one, because here CH2 group is attached, H2 is there. So it is primary. Similarly, if you come to secondary, what happens? So that one simple one. And ethylium, that is also primary because CH2, S2 is there. If CH2 attached, primary. If CH attached, secondary. If only C attached, tertiary. Now it is ethylium. Then come to, what is this one? Ethylium. If it is isopropyl, what is the name? It is called isopropylium. Now see, this is the isopropylium. And here tertiary butylium. Here what is the name? Tertiary butylium. And here that is tertiary. Because there is no hydrogen. One hydrogen secondary. Two hydrogen primary. And now alkene, if protonation, then what happen in acid medium? It gives the carbonium ion. Now see, this is a proton and this is the ethene. Then what happened? Here the pi bond, that electron is transferred, localized to this carbon. See, that is why what happened? The hydrogen, here CH2 is there, and the H plus ion, that is delocalized to this side, mean it will jump and attach here. So what is the name? The name is CS3CH2 plus. That means ethyl carbonium ion, or you can say ethylium. So next, carbocations are classified. Then how? What is the conclusion? The conclusion is carbocations are classified as primary, secondary, tertiary. Primary means CH2 group, secondary means CH, tertiary means C only, depending on the 1, 2, 3 carbon atoms are attached to carbon. That means here how can you say? When these number of carbon atoms are attached to the carbon which has central positive charge. So which has central positive charge, central carbon positive charge, then it is according to number of carbon it is added. See here, methyl carbonium or methyl carbocation. Then this is same meaning. Though now she CS3, that is the one, this simplest one, and it is also primary. And then it is called RCH2 plus. That means here CH2 group there, it indicates totally primary. And next is secondary. Secondary C. This is R, two side R are present, one side S. That means one hydrogen attached to the carbon containing positive charge, secondary carbocation, and it is tertiary carbocation. Because there is no hydrogen, you can find there is no hydrogen, and here one hydrogen secondary, two hydrogen primary, and this can telling as methyl carbocation, which acts also primary. So if you say carbonium ions are reaction intermediates, generally when you will see reaction mechanism at that time, in middle way the carbonium ions are formed, and after that it is stabilized by 1 to shifting, hydride shifting, methyl shifting, like this, then it becomes to more stable like that. That means here it acts as a intermediate, reaction intermediates, which is very helpful and which is very, very active, because as central positive charge carbon has 6 electrons. You know this is sextate, so it is very, very useful, very, very active, because it has 6 electrons, unstable. It has tendency to complete the octet. That is why it is very active. Why? Because it has 6 electrons, then it is deficient of electron. That is why it is trying to it has tendency to complete the octet. That means carbonium ions are reaction intermediates and very, very active, because central charge atom that having positive charge and 6 electron, and there is deficiency of electron to complete the octet, so it has a tendency to complete the octet. Carbonium ions combine with anyone. That means carbonium ions combine with whom? Anyone mean what? Which can donate electron, which can donate pair of electron, then only carbonium ion combine, then only carbonium ion are active. So which can donate a pair of electron to carbonium ion to form 4th covalent bond. See here, one side is a plus charge, that is having 6 electrons and positive charge, and 3 bonds are there, covalent bonds are there, and it wants to take electron from other tendency to complete octet, and which can donate the outer side agent can donate a pair of electrons to carbonium ion, then only it form 4 covalent bond. That means how many covalent bond total now? 4, and this is called 4th covalent bond. So here you can say carbonium ions carbonium ions are very active. Since carbonium ion is deficient of electrons, just now I told, because there is 6 electrons, less electron, that is why it's so unstable. If alkyl group is attached to carbon having positive charge, alkyl group attached to carbon having positive charge is more stable. That means if alkyl group is attached to carbon having positive charge, that carbonium ion to attach, then it is pumping electron, in donating electron through the bond. See here, this is the alkyl group. So here the electrons donated from this wavy area. This is a wavy area. Now electron donated from here to carbonium ion, more stable when there is no alkyl group. Instead of alkyl group, there is hydrogen. Here there is hydrogen. And so you can easily understand, because it is alkyl group, you can write here alkyl group. Since alkyl group is there, it can donate electron, pair of electrons to carbon is more stable than this. Tertiary carbonium ion is more stable than a secondary one. Why? Tertiary carbonium ion is more stable than secondary. Why? Because tertiary carbonium ion, where 3 alkyl groups are there, in secondary carbonium ion 2 alkyl groups are there. Because alkyl group donating mean here the complete the octet one and form the 4th covalent bond, and similarly secondary carbonium ion is more stable than primary carbonium ion. Why? Secondary carbonium ion, here it contains 2 alkyl group. It contains 2 alkyl groups. See here, you can observe here the secondary carbon, that means here 2 alkyl groups are there. Here one side, this is one and this is one. So this is one alkyl group, this is also one alkyl group. So there are 2 alkyl groups, in tertiary 3 alkyl groups, and primary 1 alkyl group. So secondary carbonium ion is more stable than primary one. Or you can say directly tertiary carbonium ion is more stable than secondary, which one more stable than primary. Then last, methyl carbocation. So stability of carbonium ion is reduced when electron withdrawing group is attached. You know the stability increases when alkyl group attached, because it donates electrons to the carbonium ion. But here, if the electron withdrawing group is attached, what is meaning by electron withdrawing group? They will withdraw electron from the carbonium ion. So what happened? Attached to the central positive carbon atom. And for example, NO2, CWO, keto group, carbonyl group, nitro group. These are the attached. These are called that is electron withdrawing group. Now you can observe here, if Na2 is attached, here NO2 is attached, and this side only hydrogen is attached. And which one is more stable? I told electron withdrawing group is, if attached, then it is less stable, because it will withdraw electrons from carbonium ion. And now here 6 electrons are there. If the electrons removed from carbon below that, then what happens? It is less stable. Whereas if hydrogen attached instead of any group, then what happens? It is more stable. When you compare to only withdraw group, the electron withdrawing group is attached to the carbonium ion. So what is meaning? That means if nitro group is attached, it is less stable. The stability also can be explained by the help of resonance. You know, some organic compound show the resonance. Resonance, that is a canonical structure that consists of more than one structures, and it has also one resonance hybrid structure. Now what happened? Carbonium ion delocalizes positive charge. When there is a resonance takes place, that means the ion delocalizes positive charge through the canonical structure. When there is a canonical structure and positive ion, automatically the electron delocalize through the canonical structure. So the positive charge of central carbon atom disperses over other carbon atoms. Suppose benzene, there are 6 carbon atoms. So if the positive charge of central carbon atom disperses over other mean other 5 carbon atoms of benzene and become stable. That means more canonical structure form, more stable. So what is the meaning here in terms of resonance? Carbonium ion delocalize its positive charge through the canonical structure. If more canonical structure, the more stable. Now example C, benzyl carbonium ion. This is called benzyl carbonium ion. Are you clear? Benzyl carbonium ion. That means here the group is benzene, attached to CH2 benzene. When there is a positive charge, and that is called benzyl carbonium ion. And here it is allyl carbonium ion. See CH2 double bond CH and here CH2, because there is a positive charge. There is a 6 electrons, sextate of electrons. And this is called allyl carbonium ion, and that can also exist a resonance structure. Similarly, benzyl carbonium ion, where this side C has positive charge, and that both are having resonance structure. So both are stable, more stable than propyl carbonium ion, where there is no resonance structure existing, though there is no canonical form, canonical structure existing. So what you mean? Allyl carbonium ion and benzyl carbonium ions are more stable than propyl carbonium ion. Now you can observe canonical structure of allyl carbonium ion. And now see, that is called allyl carbonium ion hybrid. Here this electron, here you can observe this pair of electron, that is pi electron jump or localized to this side, this single bond having positive charge, this side carbon has positive charge. So what happens here? It becomes to double bond, and there is no positive charge because here it is dispersed over this carbon and positive charge is not here. Now here this acquires a positive charge. Canonical structure of benzyl carbonium ion. See here, this is single bond having positive charge, C positive charge. Then what happens? The double bond here present pi electron that is localized to this bond between carbon and this carbon. Then what happens here? This occurs a double bond CH2, and in this structure this is already delocalized, and that is why, and here by stress here it localized to this bond and it acquires a double bond and it acquires a positive charge, and remaining as it is, all are remaining as it is. Now again you can see this pair of electron existing, this suppose comes to this side and here bond is formed and it forms positive charge, and this positive charge there and double bond is there. Then what happened here? And this electron localized to this bond, automatically positive charge is gone and here becomes a double bond, and this is the structure. Now see, this and this, they are called Kekulé structure, and here you can find the canonical structure of this like one. Here only the pi bond is different, here the pi bond existing is different. So if you see, this is the canonical structure of allyl carbonium and this is the structure of benzyl carbonium. Now structure of carbonium ion. In the structure of carbonium ion, the first you see carbon atom carbonium ion is sp2 hybridized. So what is the hybridization takes place in carbonium ion? That is sp2. sp2 means triangular structure, and sp2 hybridization means one s orbital and other two are p orbital. From the p has 3 orbital, px, py, pz. Here 2 orbitals are used for hybridization, and this is called sp2 hybridization, and this one sp2 hybrid orbitals. We can observe structure of carbonium ion where the carbonium ion is sp2 hybridization here, and the each orbital is called sp2 hybrid orbital, means s and p, 2p and 1s, they combine and form one hybridization, that is called sp2 hybridization, which is a triangular structure. The three sp2 hybrid orbitals, now you can observe here how many orbitals are there? 3 orbitals are there. Now here 3 orbitals are there. 1, this is 1, this is 2 and this is 3. 3 sp2 hybrid orbitals from 3 sigma bonds with 3 hydrogen atoms. Now it forms, each sp2 hybrid orbital forms a sigma bond with a hydrogen atom, that is s orbital, and other, or also you can say one simply hydrogen, or you can say any group of hydrogen, just like alkyl group. And 2 or p orbitals of carbon are used in sp2 hybridization. Now 2 orbitals out of 3 px, py, pz, only 2 orbitals are used in sp2 hybridization, and 1 is remaining, which is undergoing no hybridization, remaining on hybrid orbitals. Then what will happen to on hybridize? So hybridized orbital what, and on hybridized orbital what? Dies, on hybrid orbital means this never goes any hybridization, that is called on hybrid orbital. On hybrid, which orbital? P orbital, which of which carbon remains vacant. P orbital, one p orbital of carbon is remains vacant and never undergoes any hybridization, and 2 are only used, px, py. Suppose let px, py use and pz is vacant, remain unhybridized. And due to sp2 hybridization, the structure is trigonal planar shape and bond angle is 120. See, this is the empty hybrid orbital, and these three are sp2 s hybridization. Here sp2 s overlapping. This is sp2 s hybridization and forms a sigma bond. This is a sigma bond. So you can write here a sigma bond. This is a sigma. This is a sigma bond, and remaining empty on hybrid orbital. And this is sp2 hybridization of carbon in carbonium ion. Then what happened next? Reaction of carbonium ion, proton loss. If proton loss, what happened? A carbonium ion may expel one proton and forming alkene. That is very, very important mechanism of alcohol. Here what to do? That means here propyl carbonium ion, let here propyl carbonium ion is there. Then what happened here? Here plus sign, positive charge on the central carbon atom, and here one hydrogen is attached to this carbon. Then what happened? This pair of electron goes to this side, having changes to double bond, and this hydrogen repelled. Then what happened here? CH3, CH and CH2. That means here you can see what happens here. The hydrogen atom that coming outside and it double, here it changes to CH2 plus 2 CH2, and that hydrogen atoms expelled, because I told carbonium ion may expel proton forming alkene. Then this is now expelling, and here only this pair of electron comes to this bond and becomes to double bond. So it is very, very important. Are you clear? Proton loss mean then here what happened? One hydrogen atom become lost. How? Because the pair of electron of the sigma bond localized to the carbon bond near about the adjacent to carbon having positive charge. And after that, you can say combination with nucleophile. First one is that is addition. The next is what? Combination reaction. Combination reaction, what happened with nucleophile? Then what is nucleophile? Nucleophile means nucleus loving. Nucleus means positive charge. Who will love nucleus, that means negative charge. Nucleophiles are negative charge. So here you can say carbonium ion accept a pair of electrons from nucleophile to form bond. That means carbonium ion has six electron sextet of electron. That is why it accept electron from, that is from pair of electron from nucleophile. Now see here, Br is a nucleophile. Then what happens to Br? Since it is excess of electron, Br minus, bromide ion, and here this pair of electron comes to this side, delocalized to this CH2, then what happened here? CH3, CH2, Br. Are you clear? It accepts a pair of electron from nucleophile to form a bond. Nucleophile means nucleus loving, then Cl minus and Br minus, I minus, OH minus, the minus sign you will check here. A nucleophile, that is also neutral, also present. One is I told the nucleophile means nucleus loving, negative charge, and also has a pair of electron, only simply remaining as a pair of electron and remaining as it is. There is no negative charge, just like water and ammonia like this. Then what happens here? Let us water with a tertiary butyl carbonium ion to produce protonated tertiary butyl alcohol. That means if water react with any carbonium ion to what will produce? Produce alcohol. Now example here, tertiary butyl carbonium ion. Now it is tertiary butyl carbonium ion because a positive charge is there. Now what happened? Water has lone pair of electron. I told carbonium ion has a tendency to accept pair of electron from other. Now this electron delocalized to here, which carbon? So here what happened here? They transfer to this carbon. That means CH3 remain as it is, CH3 and single bond O plus HH. So it is called protonated alcohol. Tertiary butyl carbonium ion gives protonated tertiary butyl protonated alcohol. Then if it is tertiary protonated alcohol and also loses one proton, just reverse reaction, not reverse, again proceeding reaction. That means here what happened? It produces an alcohol. That means you can observe here that protonated alcohol, this is called protonated butyl alcohol, and here one H will be removed, then it gives what happened? It gives tertiary butyl alcohol. That means protonated alcohol, if H plus ion is removed, then it gives protonated alcohol. Then come to addition to an alkene. Addition to an alkene, then what happened here? Addition to alkene, see here, CH3, double one CH2, what is mean? This is propene structure, 1, 2 position methyl, 2 methyl propene. What is the name? 2 methyl propene. Then here you can say if 2 methyl propene, then here what happened? Here 2 methyl propene, and if it attached by carbonium ion having 3 alkyl group, and here the electron pair that comes to carbon plus, that means carbonium ion in tertiary butyl carbonium, here it accept electron from alkene. Then what happened? This C acquires positive charge, and this one having no positive charge now. See here, CH3, C here positive charge and continue. Then what is the name here? And here you can say 1, 2, 3, 4, 5. That means it is a continuation chain. 1, if you count this one, 1, and now you can observe there is no hydrogen. This is tertiary carbonium ion. And here how many groups are attached, and how many? 1, 2, 3, 4, 5. And 2 position there is a methyl group. 1, 2, 3, 4 position there are 2 methyl. So 4, 2, 4, 4 trimethyl. 1, 2, 3, 4, and that is tertiary tertiary butyl carbocation or carbonium ion. Carbonium ion is added to alkene to produce bigger carbonium ion. Only you can say what type of carbonium ion. For first one, only 3 carbon, where it is 1, 2, 3, 4, 5, 6, 7 carbonium. 7 carbons. This is a bigger carbonium ion. Next come to carbonium ion is added to alkene to produce bigger carbonium ion, and molecular rearrangement, how it is helpful for in rearrangement, that is in mechanism. It gives more stable carbonium ion. In molecular rearrangement, the intermediate step is very big, more stable carbonium ion it produces. Stable mean what? Tertiary is more stable than secondary. Secondary is more stable than primary. That means here, suppose secondary is there, then it tries to give tertiary. If primary is there, it tries to give secondary. That means if it changes to primary to higher secondary or tertiary, it is having more stable carbonium ion. A carbonium ion rearranges to secondary carbonium ion, just now I told. Similarly, secondary carbonium ion rearranges to tertiary carbonium ion. Example C. Primary to secondary carbonium ion. This is primary one because only simply long chain is there. Only what? A long chain is there. And here CS2 attached here plus. That means if this is primary and this is butyl because the long chain carbonium ion. Now it gives a secondary butyl carbonium ion because CH. I told if CH is added, then it is secondary. 1, 2, 3, 4. Secondary butyl carbonium ion. Primary to tertiary. See, this is primary. Why? Because it is as CS2 plus. If it is CS2 plus, then primary. If only C plus, then it is tertiary. No hydrogen. Now, here primary changes to tertiary for stability. Then what happened here? CS3, CS2 remain. This side, from this side you count 1, 2 methyl, and in one position there is a plus charge. That is why 2 methyl 1 butyl carbonium ion primary. Similarly, it is the what happened here? It changes to tertiary. Primary changes to tertiary. Then what happened? 1, 2. See, this is called 1 and 2. This is 3. This is 4. So it is 2 methyl, 2 butyl, mean secondary 2 position there is a plus charge carbonium ion, 2 butyl carbonium ion. That means it has no H in the carbonium ion, the place of carbonium ion. This is tertiary. So here that means how this is a third example, secondary to tertiary. Secondary means CH, where secondary means C plus H. Only one hydrogen is there. That means here it is called secondary. And it is tertiary. Tertiary means here the carbonium ion is that one where no hydrogen. So what is the name first? You see 3, 3. 1, 2 and 3. And this is 4. So 3, 3 dimethyl 2 butyl carbonium ion. 3, 3 dimethyl 2 butyl carbonium ion. This is secondary. Changes to what? Tertiary. So what is the name? 2, 3 dimethyl. And next 1, 2. This is 2 position. 1, 2, 3. So 2, 3 dimethyl 2 butyl carbonium ion. That is tertiary. And there is no hydrogen here. Then come to hydride shift. What is meant by hydride shift? During changes from primary to secondary, secondary to tertiary, or primary to tertiary, like this, here generally migration of hydrogen with pair of electron takes place. That means migration of hydrogen with a pair of electron takes place to other carbon. That means here it changes to other carbonium ion, higher carbonium ion. Higher mean primary, secondary, primary changes to secondary, secondary changes to. Similarly, alkyl shift. Alkyl shift means alkyl, which alkyl? Alkyl group. Alkyl group is also shifting with its pair of electrons, bonding electrons to the other carbon atom. That means here there are two types of shift. One is hydrogen shift and another is alkyl shift. So here what happened? Hydrogen means you can say hydride shift and alkyl shift. If the migration group moves from one atom to very next atom, it is called one. Others also there is 1-2 shift. Mean first you count as 1, the group where the electrons moves migrating, and second atom, next atom or adjacent atom, that is next atom, that is called, if it is shifting from 1 to 2, then it is called 1-2 shift. The migration group, it moves one atom from one atom to other atom, one carbon to other carbon. Then what happened? It is called 1-2 shift. Now see hydride shift, how it is possible. See, this is the, what happened is, this is the hydrogen having pair of electron, it moves towards here and it occupies positive charge, and this one a pair of electron. So this is called hydride shift. Then come to alkyl shift. What is alkyl shift? Alkyl shift means here alkyl group will shift. Alkyl group will shift. Now see, after shifting, the R comes to here and it occupies positive charge. So now you can say this is called alkyl shift. So during alkyl shift, the carbonium ion changes whether primary to secondary, secondary to tertiary, like this. So this is very important in the rearrangement. Alkyl shift, hydride shift, 1-2 shift. So here I want to say this carbonium ion is very, very important in reaction mechanism. How the conversion of one stage to other stage also is responsible due to carbonium ion. After that, I will proceed in next video, carbanium ion, and I hope you understand the total carbonium ion and its effect, and how the carbonium ion is produced, how it is effective to other reaction, and hope you will subscribe my channel BL Das Short and Sweet in Chemistry, and thanks for watching my video, the carbonium ion, and that is very, very important. And next class I will proceed carbanium ion you can say, or only simply say carbanium. Thanks again to all.